So the question here, mass is, I think, always easier, right? So these masses are, if you imagine this as a sheet of rubber, they're depressing that sheet of rubber down in there. So P is definitely at a lower potential, lower height than Q, and so it makes sense that if we go from Q to P, that we're going to decrease the potential, right? So in this case, that this minus sign makes sense to me. Okay. Now, at the end of the day, we're going to do exactly the same thing. The work we do is going to be the change in gravitational potential times the mass. Okay, and the change in gravitational potential will be the final minus the initial. Right. So let's figure out the potential at Q. Right. So VQ is equal to, and it's going to be what is it? It's a negative G, and then let's figure out for mass A. So negative G times 2.3 E12, right? Over, and then let's see how far. These are all a meter, right? Okay, so let's see for point Q, right? We're doing point Q, so we are 1 squared, and then 1, 2, 3, 4, 5 squared. Right, and this is the potential due to A. Right, and then the potential due to B is minus G times B is 8.7 E12. What is that? Is that tera kilograms? That's kind of a weird way to say it. Okay, let's see. And then we're looking at Q. We're looking at the potential at Q due to B. So it's 1, 2, 3, 4. 4 and 2. 4 over. All right, now let's just double check our doing here. Let's see. 1 over 1, 2, 3, 4, 5, and then A is 2.3, so we got that. And then this guy is 1, 2, 3, 4 over 2 down, so we're good. All right, so let's plug that in. That's going to be negative 6.67 E minus 11 times 2.3 E12 divided by the square root of 1 squared plus 5 squared. Right arrow plus negative 6.67 E minus 11 times 8.7 E12 divided by the square root of 4 squared plus 2 squared. All right, so this potential is negative 159.8 joules per kilogram. That's a Q, right? Now let's figure it out at P. It's going to be minus G times 2.3 E12 over the square root. Let's see, okay, at P. How far are we from B? Oh, sorry, how far are we from A? We are 1, 2, 3, and 1. 3 squared plus 1. So the voltage at P due to A is this. Is that right? 3 over 1, 2, 3, 1. Okay, this is good. And then plus negative G times 8.7 E12 over, and then the voltage due to B at P, the distance is just 2. Right? Okay, I love that. Okay. So now I'm going to have to type it in there, and 8.7. So literally I'm just making that a 0 and a 2. Square root of 0 squared plus 2 squared. I'm so lazy, I'm just using the expression I just made and changing it. So 3 squared plus, oh, this is 1 squared. If you don't square that 1, big bad things happen. Right? Be like not using the electoral college. All right, here we go. Are you ready for this? All right, and I'm getting this is minus 338.65. So just as we imagined, this is lower down in the sheet of rubber than this one, okay? Now we are going to move a mass from Q to P, right? So P is the final one, right? And Q is the initial, right? So our change in potential is equal to the potential of P, which is where we end up, right? See, this is why I'm so bad at this. So negative 338.65 minus the potential at Q, which is where we started. That's our initial, right? Because we're going from Q to P. So minus a negative 159.8. Okay, so that guy minus this guy is actually negative we go down 178.8 joules per kilogram. And now the work done is mass times change in, right? Our mass is 4.5 times negative 178.8 joules per kilogram. So times 4.5. And I get that the work I did was negative 804.66 joules, or negative 805 joules, right? All right, happy hunting.